Now, after we answered question number 5 on page 181 about how you can find the missing number in each set of equivalent fractions, let's go and do the opposite operation, which is division or dividing, to write each fraction in its simplest form. Now, equivalent fractions or simplifying fractions, you can find equivalent fractions to make your numbers easiest to handle by finding the lowest equivalent fraction possible. To do this, we just have to divide the numerator and the denominator by a number that both can be divided by with no remainder, okay? Even if the number is so big, if we have 160 over 200, we know that we can divide these two numbers by 10. Dividing these two numbers by 10 will omit the zeros on both sides, so we get 16 over 20. Again, dividing these two numbers by 4 for both the numerator and the denominator, we will get 4 over 5. And this is actually the simplest form because it looks like it's already a relatively prime number to each other. It means there's no common factor to be divided on. Equivalent fractions, you can use different languages for making the fraction as small as possible. We can use lowest terms, simplifying, or cancelling down. Watch out for this language in the future. Finding smaller fraction is often called simplifying or cancelling down, or sometimes even expressing a fraction in its lowest term. This fraction is as simple as we can make it because there is nothing that we can divide both the numerator and denominator by. Equivalent fractions, for example, we have 15 over 45, 60 over 80. The trick is to look for a number that both the numerator and the denominator can be divided by. We want numbers bigger than 1. Since any number divided by 1 gives you the same answer, we'll call these the common factors, okay? The numbers that can be divided by the numerator and denominator, we call it common factors. Now, if we divide this by 3, and this by 10, you would get the answer of 5 over 15, 6 over 18 for 60 over 80. And then divide them again by 5 because you can divide 5 by 5 and you get 1, and this is the lowest form. 5 by 15, how many 5 are there in 15? We have 3 5s. And then divide 6 by 2, which is 3, and divide 8 by 2, you get 4. So 1/3 and 3/4. Now, equivalent fractions, if the number is 1, which is the numerator, we know that we can now stop. If the top and the bottom number are not divisible by the same number, then you stop because this is the simplest form, okay? Now, they have no factors in common other than 1. They have no factors in common other than 1. So this is where you stop, okay? And this is how you actually simplify a simple fraction with just dividing. Now, since we know that we need to simplify these fractions to their simplest form, in question number 6, you have the first one, which is a 4 over 12. 4 over 12, we need it to be simplified to the simplest form where we can't simplify it anymore. So if I divide 4 by 4, I'll get 1. If I divide 12 by 4, I'll get 3. The answer is third, okay? For B, we have 6 over 9. We need to divide it with a common factor. The common factor here, as they rely in the times table of 3. So we divide by 3. 6 over 3 we have 2. 9 over 3 we have 3. For this particular one again, we need to know where does these both numbers relies, which times table they relies on, or multiplication tables, okay? So here they rely on table 7 times 7. If I divide 14 by 7, I get 2. If I divide 21 by 7, I get 3. And the answer is 2/3. 15 over 20, we can divide right away by 5, and we get 3 over 4. 18 over 20, we can divide by 2 to get 9 over 10. Okay, now for F, 20 over 50, we just divide by, let's say, 10. If we divide by 10, you can have 2 over 5, and this is the simplest form because there's no other common factor to make the numerator and denominator divisible. For the rest, I'll just leave you to answer by yourself. You have G, H, and I. It's easy, just go through it, okay? Now, one of the questions in exercise number 6 on page 151, you will find or face improper fractions. Now, improper fractions means to answer these or to simplify these improper fractions, you need to understand the difference between proper and improper fractions, okay? In proper fractions, the numerator is actually smaller than the denominator, okay? Which is a normal fraction. In improper fractions, the numerator is always bigger than denominator. In this case, we need to understand how to simplify this improper fraction. Now, a mixed fraction, or what's meant by mixed fraction, is a whole number and a proper fraction all together. Mixed fractions and improper fractions are the same. We can use any to show the same, okay? As 1 3/4 or 3/4 or 7/8. Now the rules for improper fractions turned into mixed fractions or mixed fractions into improper fractions. For the first one, we need to divide the numerator by denominator. The question is the leading number and the remainder as the new numerator, okay? So now we have 9/8. 9 divided by 8. How many 8s do we have in 1? 9. We only have 1. 9 subtracted by 8, we got 1, okay? So we do this. We take 1 as a whole number, okay? 1 as a whole number. The remainder, or what's left from the subtraction, as the denominator, and the number here as denominator.